So in our last lesson for circles, we're going to look at some more relationships between arcs and their arc measures versus the angles that cut them off, the related angles, whether they're inscribed angles, central angles, or just created by the intersection of two segments like a chord or a secant or a tangent. And I'm actually going to be scrolling up and down a little bit on here, so hopefully it doesn't make too many people dizzy, because the way I have it set up, we have our three different patterns that we could have. And technically, pattern 2 is going to look a little familiar once we get into it. But the problems that I have related to them are both directly underneath. So we'll do one pattern, do a couple example problems, and then do the next pattern, and so on. So again, we have three possible scenarios. Let's start with the most straightforward one that you're probably going to see a little bit more often. And this is where we have two chords that intersect inside. So again, this is a slightly different relationship that we're looking at in terms of angles and arc measures rather than the segment pieces that we looked at before in our lesson 10, 10C, I believe it was. And so the relationship that we have here is for the measure of angle 1. Let's see, I want to be on red so it pops. So measure of angle 1. It's related to the two arc measures. First one is very apparent. First arc measure it's related to is arc AD. And then the second arc measure it's related to is BC. And you'll notice if I go in a different color, or actually let's do a highlighter on this one. Let's do blue highlighter, cool. And so all three of these are in a nice straight line compared to each other. And so that's always going to happen with this kind of relationship. And the relationship is, let's go back to our pen tool. The measure of angle 1 is going to be the same thing as the measure of arc AD plus the measure of arc BC added together and divided by 2. So in other words, it's the average of those two arc measures. Okay, second piece, again, it's an idea that we looked at all the way back in Unit 2. If we were to add together angles 1 and angles 2, or angles 1 and 2 in this kind of central part of that circle, which of those two angles add together to if they make that nice straight line along their two sides? Well, they should add up to 180 degrees. And so there's two different scenarios where we might have to use the same pattern. And it all depends on, do we have things in that nice straight line like our arc AD, angle 1, and arc BC? So let's do a couple problems on this first before we look at our other patterns. So here we go. So we're going to look at examples 1 and 2. So let's start with example 1. Okay, we're looking for the measure of arc AEB. So we have a problem here. AEB, is that in a nice straight line from the arc measures they gave us, the 45 and the 109? Not so much. So I actually have to do another problem first before I can solve for the missing angle that they want us to use. So let me change over to blue. So I know 45-degree arc and 109 arc. So that means if I kind of look at the straight line in between those two, I can only figure out one of these middle angles here, like the blue angle. And so I'm going to go ahead and find that first. So we're going to call that X for the moment. So I know that angle X is going to be the same thing as adding up 45 plus 109 and dividing by 2. Well, we don't have anything really to solve. We just have to simplify that expression. I would suggest doing the 45 plus 109 first. That gives me 154. And 154 divided by 2 gives us 77 degrees. Okay. And so again, look back at your diagram. They want us to find the red angle, angle AEB. But what would the red angle and the blue angle added together make? They would make 180 degrees. So to find the red angle, again, angle AEB plus the 77 degrees that we found, the X, should add up to 180 degrees. So that means angle AEB, the one that they were looking for, 180 take away 77 gives us 103. And if we look at the diagram, it does look like that could absolutely be an obtuse angle. And so we actually used both of the rules that we had up with that scenario 1. So first rule we used is we kind of found the average of those two arcs that were in a nice straight line with each other to make the interior angle. And then we subtracted from 180 to find the other angle that made the straight angle. Alrighty, let's try another one very similar. So number 2, and you'll notice the numbering looked a little different because I knew we were going to set it up that way. So number 2 is asking us to figure out arc LK. So there's arc LK that we don't know. So let's call that X, just so we don't lose track of which one we're using. Okay, and I'm noticing that's actually pretty close to the 62. So if I draw a nice straight line, I can get between the X and the 62 and straight through, and that actually leads me to the 74. So I have 2 arcs that I know about that I have labeled. I have a 74 and I have an X. And then the angle that lines up with them is the 62. Okay, so our rule is the angle towards the middle equals the 2 arcs added up together divided by 2, the 2 arcs averaged. So let's set that up. So our 62 degrees should equal 74 plus X divided by 2. Now that doesn't look as pretty with the fraction, but how can we undo the fraction? How can we get rid of a divide by 2? Well, do the opposite, just add, or excuse me, multiply times 2. So that would cancel out our 2's for us. And then we're left with 2 times 62, otherwise known as, I believe, 124. Oops, let me go back to blue. 124. And so that equals our 74 plus X, no more fraction, and then we just subtract 74 from both sides. So 124 minus 74 gives me 50 degrees. So the measure of arc LK is 50 degrees. So that's our first pattern. So again, average the 2 arcs together to make the angle in the middle. Alrighty, pattern number 2 is going to look really familiar. So pattern number 2 is an intersection on the edge. So if I look at angle 1, so let me highlight angle 1. Wait a second. The corner, the vertex A, is sitting right on the edge of the circle. Now, we actually just talked about this in lesson 10C. We can treat this just like an inscribed angle, which is the angle is half the measure of the arc. So we can actually do the problem that way. So the arc that's intercepted by angle 1 is a minor arc. So that's going to be arc AB divided by 2. That's it. So this actually is a review rule. It looks a little different because we're not used to necessarily combining that with the tangent like we have at the bottom of our diagram, but it's the same rule from last lesson. We can do the same thing with angle 2. So again, if I highlight the sides of angle 2, they cut off our major arc BCA. So that means to find angle 2, all we need to do is take measure of the BCA, again, our major arc, divide by 2. That's it. Alrighty, so let's do some practice problems. So this is going to be 3 and 4. So I'm scrolling down right below. Okay, so measure of arc XY. Well, I have the same kind of problem I did with number 1. I don't have the angle, that little skinny angle, already figured out. So I need to do a little bit of legwork, or I kind of need to work the problem backwards. So there are a couple different ways to do this. My suggestion would be, if I know that 151 degree angle, which is right here, can I figure out what the skinny angle is supposed to be? Because what should those 2 angles add up to? So 180 minus 151. 180 minus 151, well, that gives me 29 degrees. So that small measured angle is 29 degrees. So again, that little angle 29 degrees, what's that relationship with the arc measure? Well, the arc measure is going to be twice the angle, or the angle is half the arc measure. So the measure of XY is going to be 2 times 29 degrees equals 58. Again, same way we approached the problems last lesson. Okay, number 4. Same kind of problem, but again, they didn't quite give me the correct information. I've got to figure out angle X, but they gave me the arc on the other side. So let's approach this one a little differently. So let's see here. We have 160 degrees is this section, and we only have one other section for the entire circle. Well, what do we know that the arc measures going all the way around a circle should always be adding up to? If everything adds up to 360 and we already know the 160, with the leftover, that's just going to be 360 minus 160, otherwise known as 200 degrees. And so if the arc measures 200 degrees, how do I use that to find the angle? Well, the angle is half the arc measure. So X equals 200 divided by 2, aka X is 100 degrees. And again, that looks like it should be appropriate. It's just slightly larger than the 90-degree angle, so that makes sense. So again, really, these two were just a review from last lesson. Alrighty, third rule, and then we'll do a couple harder problems. Okay, so third rule is when we have the intersection on the outside. And so just like we did before, I actually have a combination of secants and tangents, and it could be any combination. So I could have 2 secants. We'll do a couple problems with that. It could be a secant and a tangent, could be a tangent and a tangent, but they all follow the same rule. Your angle A, so this angle here, is going to be compared to the 2 arcs it cuts off. And so because the intersection is the outside, it's not like our first rule. So our first rule, we added up our arc measures, divide by 2. Our intersection right on the edge was just a straight divide by 2, because we didn't have any weird intersections to take care of. Everything happened on the edge of the circle. And then on the outside of the circle, it's going to work with arc BD minus arc BC, divide by 2. So intersection on the inside, add them up, divide by 2. Intersection on the edge, just divide by 2. Intersection on the outside, subtract and divide by 2. So it's still kind of the same big rule, just minor tweaks with where the intersection happens. And don't forget too, what is the sum of all your arc measures that we just used in example 4? Everything adds up to 360 degrees, which is going to be relevant in 1 or 2 problems. Alrighty, so let's try this out. So example 5. So example 5, we're looking for angle X, and we need to know the 2 arcs that get cut off by that angle. So if I follow my sides back, I want the arcs that are inside that space that the angle makes. So I need to know this little guy here and this bigger guy here. Well, I already know the 80. And in fact, I know everything else in the circle except for that little arc that I need. So that little arc, how am I going to find that if I know everything else going all the way around the circle? Well, again, all of our arcs always add up to 360 degrees. So just subtract out what you know to figure out what you don't. So we're going to do 360, take away the 100, take away the 80, take away the 110. So 360 minus 80 minus 100 minus 110 comes down to 70 degrees. And so now we can apply that pattern. Big arc minus small arc, divide by 2. So X equals big arc minus small arc, divide by 2. And all we do is simplify. So 80 minus 70, well, that's just 10. So wait a second. We have a very small angle. X equals 5 degrees. And again, we kind of knew going into this, this was going to be a really, really small angle because look the size of it. Look how narrow that angle is, how little space is actually in between the sides. So it makes sense with the problem. Alrighty. Then we look at number 6. So with these problems, again, I'm noticing I don't have quite enough information labeling the diagram. So let's see what we can work with on this. So I have the 34, I have my outside angle. I have one arc labeled with the X, And I would need this other arc outside, but nothing's there. So again, we know we have x. What should the entire circle all the way around add up to? 360. However, the only thing we know is the x. So I'm actually going to label this as 360 minus x. If we knew what x was already, then we could do that subtraction and get a value. So why not do that with a variable? So then let's plug this into our problem and see what happens. So the angle, 34 degrees, equals the big arc, 360 minus x, minus the small arc, divide by 2. So this looks a little bit weird, but I can simplify this a little bit. What's negative x minus x? Or minus 1x minus 1x? So that's going to come out to 360 minus 2x, divide by 2, and now we just solve for x. So let's do the same thing we did before when we had a fraction we didn't want to deal with. Let's go ahead and multiply both sides by 2. So that cancels the fraction on the right-hand side. And on the left-hand side, I am left with 34 times 2, otherwise known as 68. And all it does on the right-hand side is cancel out the fraction, so no more fraction. Okay, let's subtract 360 from both sides. Now that's going to look a little weird because, hey, now I have a negative 2x left on the right-hand side. See, 68 minus 360 gives us negative 292. And here's why I know it's okay. What's going to happen when we divide both sides by negative 2? Well, with the x, there's just no more negative. And let's see, negative 292 divided by negative 2. Well, negative divided by negative is going to give us a positive, and it's going to come out to be 146. So let's think about this. With the size of the circle, again, half the circle would be about like this, and half the circle is how many degrees? Well, it's 180 degrees. We got a little bit less than that with 146, and our arc x is a little less than half the circle. So that makes sense with our answer for x. Alrighty. So then what I would suggest doing if you're still having difficulty figuring out, well, how do I know which one of these patterns to look at? This is where I would suggest pausing the video. And actually, if I scroll up a little bit, you can find this on the version I have linked on Schoology, and I'll put an extra link as well under our video link. But check out this Geogebra demo, the M/A5MWZ, that fun link looking there. And so I've actually created some diagrams where, well, I borrowed some diagrams and tweaked them a little bit so it showed all of the relationships. So you can pull the circles around to see what the measures are actually going to be and if they follow these patterns. So that would be a good thing to do. Pause the video, check out that demo, and then come back. And I've got 2 more examples on the rest of this video to check out. All right, let's look at our last 2 examples. So again, this is going to be kind of mix and match of our 2 rules. So number 7, we're given some measures. Let's go ahead and label those before we do anything else. Okay, measure of arc ED, so that's this arc here, is 9x minus 3. Measure of arc BF, well, that's 15x minus 39. And if this is going to be any help whatsoever, then I should be able to go in my nice straight line like this. And hopefully it's one of those angles that has C as its center, either BCF or ECD. And indeed, we have BCF as our angle. And so here we go. So BCF is this guy right here, and that's 11x minus 9. Alrighty. So angle intersection is inside. So that means I add up the arcs and divide by 2. So here we go. So add up the arcs or angle measure. So 11x minus 9 equals the arc measures. So 15x minus 39 plus 9x minus 3, all divided by 2. Okay, get rid of the fraction. Go ahead and multiply both sides by 2. So that's going to give me 2 times 11x minus 9 And I haven't done anything with the numerator yet, so let's just leave that as is for the moment. And now let's go through and simplify. So on the left-hand side, let's distribute the 2. So we have a 22x minus 18. Right-hand side, we can combine the 15x plus 9x, so that gives us 24x. And we have negative 39 minus 3, so that's going to be a negative 42. And now we just have a two-step equation. Let's go ahead and subtract 22x from both sides. That'll leave me with negative 18 equals 2x minus 42. And then add 42 to both sides. So negative 18 plus 42 gives us a positive 24. So x equals 12. Okay, let's go back and double check. Is this what they actually wanted us to solve for? And so unfortunately it is not. They want us to find the measure of arc ED. Well, we have that labeled, so that's actually not too bad. So that means measure of arc ED, well, that's equal to 9x minus 3. And we just figured out that x was 12, so plug in a 12. So 9 times 12, 108. And 108 minus 3 is 105. So measure of arc ED is 105 degrees. Alrighty. Again, trickier problem with the algebra, but the setup on this one was actually more straightforward. So I have a feeling we're going to have the same sort of thing in our last example. So number 8, they gave us arc NJ. Okay, so arc NJ, that's 170 degrees. Arc MK, 5x plus 8. And angle MLK, which is this one, gives us 4x plus 3. So same kind of thing. Wacky algebra, well, not really wacky algebra, but some algebra that'll take a few steps, but the setup is very straightforward. Intersections on the outside. So do we add or subtract with our arcs? Yeah, we subtract. So angle equals big arc minus small arc, divide by 2. So angle equals big arc minus our small arc, which I'm going to put in parentheses. You're going to see why in a sec. Divide by 2. Excuse me. So I need to do a couple things on here, but first let's get rid of that fraction. So let's multiply both sides by 2. And again, I'm going to go ahead and put parentheses around there. Why am I doing that? Now, I want to remind myself I have to multiply the 2 by the entire 4x plus 3. So times 2 on the right-hand side clears the fraction. On the left-hand side, we have a 2 times 4x plus 3. So again, you'll notice I'm not actually doing any simplifying. I'm just rewriting what I have, because if I try to do too many things in one step, that's where I make my typos. So distribute our 2 on the left. Gives us an 8x plus 4. Excuse me, 6. Goodness. On the right-hand side, we have minus 170, but we have a negative and then the parentheses. We have to subtract all of the 5x minus 8, which means we really have to do a minus 5x and a minus 8. That's why I wrote those parentheses, to make sure I didn't forget to subtract both terms. And so combine them. We have, let's see, 170 minus 8. So that's going to give me a 162 minus 5x. Let's go ahead and add that 5x to both sides. So that'll give me a 13x plus 6 equals 162. Subtract a 6 from both sides. So 162 minus 6, I believe that gives us 156. Yep. And divide both sides by 13. Gives us a very nice answer of 12. But same thing as before. If I scroll back up a little bit, you'll notice it wants us to find the measure of angle MLK, which we have labeled as 4x plus 3. So measure of angle MLK equals 4x plus 3, aka 4 times 12. plus 3, or 48 plus 3, or 51 degrees. Alrighty, so today's practice. Again, Friday, we're taking a little bit easier. You have a graded practice on Schoology, so you have a few extra attempts on there. But as always, if you try it once or twice and still aren't understanding why you might be getting anything incorrect, let me know. I can coach you through, and then you can finish up for getting a higher score. Have a great Friday.